Hello, welcome to another Minecraft clone tutorial series. Today I'm going to be showing you how to create the block class and how to use it in the chunk class. We're not going to be able to cover every single thing today because this is a very large topic, but I'm going to basically go over the structure of how it works and then get a couple blocks drawn properly using chunk meshing. So first, we're actually not inside of the original project. This is my own little personal Minecraft clone, and this is the block type.cs class here, or not class, but file. I just wanted to go over everything that we're going to be doing from a structural perspective and just make sure that it all kind of sort of makes sense before we just start writing, because it's a lot to cover. So the first thing is we're going to be dividing our block into 6 faces, and this is so that we can only add the appropriate faces to our chunk in order to optimize it. So for this, we're going to create a new struct, and this is just going to contain our data. Ignore the brightness, we're not using that for ours. This is just going to have the vertices and the texture coordinates. I'm calling them UV, that's the appropriate name. And then we're going to make an enum for the block types, however we're not going to cover that in this video. And then we have the actual block data here. And the block data will simply contain the raw data here. And we're going to be using this in our block class. And in the block class, you'll notice that it has a position and an ID. Ignore the ID for now. We're just going to work on the position. The position is taken in the constructor. And what we're doing here, well, this is a lot of code. All we're doing is we are just taking the original raw face data, which is, remember, the block drawn at the origin, and we are transforming it based on this new position that we give it. And here we're doing this with this method called add transform vertices. And all we're doing here is we are just looping through it. We have a debug statement here. We're looping through it, and we're just creating a new vertex with this the original origin plus the position and returning it. And so this way we can define the data at its origin and then move it wherever we want. So with that being said, then when we go to the chunk class, in basic terms, while it is a massive class, all it's doing is it's taking the data from the all the different blocks, compiling it into one big pool, and using this pool to draw with only one draw call, which is a lot faster than individually drawing every single block. So that being said, let's actually get coding. So the first thing we want to do is create a new folder. I'm going to add a new folder, and this folder is going to be our world folder. And then we're going to add a new item, and this item is going to be our block data.cs. This is just going to contain different things about our block data. So go ahead and remove the class. First thing we're going to do is we're going to make a public enum. This is going to be our faces. And this is just going to contain all of our faces. It's just making it easier to access this stuff. So front, back, left, right, top, bottom. And this is just because I prefer this to string values, because string values you don't really know if you entered. You could like accidentally capitalize something that isn't capitalized, stuff like that. So I prefer to use enums in this situation. And so with this, we're going to create a couple more things. So the first one is going to be the raw face data. And so for this, we're going to basically do a public, and this is going to be a read-only dictionary. And this dictionary is going to contain faces for the keys, and then it's going to contain a list of vector. Or no, it's not, sorry. We need to do one thing before this. We need to actually create the struct for our face. So what we're going to do here is we're going to actually create the struct first. So we're going to do a public struct face data. And this is going to contain a public list of vector3 called vertices. And then it's going to contain another list of public list vector2 of our UVs. That's all we're going to have inside of our face data for now. And we don't actually need to add these UVs here, but I think I'm going to do it anyways. And so I guess for now, I'm going to simply do, for this, I'm going to do vertices only. So I'm going to do a list of vector3. We're not going to be using this face data yet. And this is just going to be a dictionary with the key being the faces and then the value being the list of vector3s. And this is going to be our raw vertex data, and this is going to be a new dictionary. And here we're going to create our raw vertex data. And for this, we're going to reference our original data, put it on the left side or the right side, and then just take this data that hopefully we have nice and organized and turn it into this raw vertex data. So for this, we're going to actually need to surround this with something. So I'm going to do a struct. I'm going to do public struct face data, and then I'm going to put this inside of that. And I'm actually not going to call it face data. I'm going to call it raw face data. And then we need to do, okay, so in this struct, we actually need to make this static so it doesn't give us that error. I mean, here we're just going to define our different faces. So for this, I'm going to make a new pair faces dot front, and this is going to be a new list of vector3, and this list is just going to contain our front face. And just shift that over, make sure it's organized, and then we just want to make a new one. So for this, I'm just going to copy and paste this 5 times. So 2, 3, 4, 5, and wow, that got really unorganized. Let's backspace that, make sure that it's organized. Organization is key with all these giant data structures. Left, right, bottom, and now just simply take this data that we have here. For some reason it's out of order. Paste this in, make sure that the right's going in the right, left going in left, etc. And just paste this data in place. So the back face here, I'm going to paste this here, and then the right face, or the left face, whoops, the left face here is going to go right here, and then the top face is going to go on the top, and then the bottom face is going to go on the bottom. So now we have our raw face data, our raw vertex data defined. So with this, we can now create a new class. This is going to be our block class. So new item, block.cs, and let's go ahead and define everything that's going to be in here. I'm going to reintegrate that so we don't have to look at 2 things at once. And here we have our block class, and this is, I'm going to just write out all the methods first. So we need a public block, and then we need a public void add transformed vertices, and then we need a public void get face, and this is going to be faces face. And now we need to do some different things here. So first thing we're going to do is I'm going to do public vector3 position, and this position is going to be given to us in the constructor, especially if we spell it right. Now we can do this dot position equals position, and then what we're going to do is we're going to create our data from this. So here we're going to go back here and we're going to make sure we spell it right. We have the face data, which contains our vertices and our texture coordinates, and I'm going to create a new list here, and I'm going to do a list, a private list of, and then, or actually it's a dictionary, my apologies, a dictionary where the key is going to be the faces, and then the value is going to be the face data. This is going to be our faces. So here we're going to do faces equals a new dictionary, and then here we're going to actually define everything inside of our dictionary. So first thing we're going to do is we're going to do faces.front, and then what we're going to do is we are simply going to do for our value, we are going to do add transformed vertices, and then we're going to need to send it an argument. And I don't know why it autofills that, but for this, we're going to take in a list of vector3 vertices for here, just so we don't get an issue here. And we're going to also return a list of vector3 here for our add transform vertices. And so for this add transform vertices, we're going to send the face data raw vertex data, and then it's going to be and this is going to be at faces.front. And we're getting a bit of an error here. Oh, I made a mistake. So we're actually using the face data. We're not just getting a list of vector3. So here I'm going to cut this, but save it. And then for the value, I'm going to do a new face data. And this face data is going to have the vertices equal to this. and then the UV we're going to handle in a bit. First, let's go ahead and get this data working fully. So for this, let's go ahead and first add this extra parentheses here. And what we're going to do is we're going to create this add transforms vertices. So what we're going to do is we're going to make a new list of vector3 inside this method here. And this is going to be our transform vertices. And then we're going to do for each vertex and vertices. This is being very helpful. We're going to do transform vertices dot add, and then we're going to do vert plus, and this is going to have the position. So for this, we already have our position defined up here publicly. So I'm just going to do position here since we're not going to be changing that. And then all we want to do is return the transform vertices at the end. And that is transforming our vertices properly. And for the UV data, we can define the basic UV data here. We can define a default one here if we want to. And I could definitely do that. So I'm going to do just a simple vertex data here somewhere. Actually, since it's temporary, I'm just going to put it at the top here. I'm just going to say a list of vector2 UV equals a new list of vector2, and here, oh my gosh, why is it doing that? Here, you know, C# Visual Studio sometimes annoys me. Here, since the vertex data is the same for all 6 faces, we only need to add it once. This is going to change when we have multiple blocks with different faces, of course, but this is going to be our simple default UV. And so this will just simplify it a bit. So now for our UV, we're just going to do UV equals this dot UV. Actually, I'm going to call it dirt UV, just so we don't have any confusion. This UV equals dirt UV, and that's our faces dot front. So now we can add all of these using this system. So let's just copy this over, add our comma. Oh, we don't actually, the parentheses is supposed to be here, and the parentheses is supposed to be here, and then we don't need this parentheses here. Whoopsies. Okay, now we can copy it over properly. It's a little bit of a mess, like organizationally, but there we go. We have our 6 faces, and now all we have to do is we do back, left, right, top, bottom, and then here we do the same thing. So back, left, right, top, bottom. And so now all we're doing is we are storing this in dictionaries where we can use this get face and then return it. So all we're going to do here is this is just going to return a of type face data, and we are going to return faces at face. And see how simple that is? So we're just creating this dictionary where the keys are of this enum type, and we're returning our vertices and our UVs, which makes it very, very simple to get the data here. So this is actually relatively organized, especially compared to my original example. So I'm pretty impressed with that. Let's go ahead and create a chunk class now that's going to be using this data. So here I'm going to create a new item, and this item is going to be a chunk.cs. And here we're going to create a couple of things. So the first thing we're going to do is we're going to do a private list of vector3, and this is going to be our chunk vertices. And then here we're going to do a private list of vector2, and this is going to be our chunk UVs. And then we're going to do a private list of unsigned integers, chunk indices. And then we're going to have a constructor, so public chunk. This is going to take in the position, and I believe that's it. So now we need to define some constants here. So I'm going to do a constant int size equals 16, and I'm only going to use size. I'm not going to use width and depth because chunk isn't even 16 by 16. We are going to be working with height in the future, but we're not going to do that right now. I don't think so, or we might actually. So I'm going to just write one constant int chunk height, or I'll do height here, equals, and let's just do 32, I guess. So now we're going to do one more thing. We're going to do our public vec3 position, and this is just going to be given to us in the constructor. Yeah, we got to make sure we spell it right too. Position equals position. That's pretty cool. Now we need a couple methods to actually take this data. So the first thing we need to do is we're going to do a public void gen world. And this is going to generate the actual data, but we're not going to use that right now because it's too much to do in one tutorial. Then we're going to do a public void gen blocks. This is going to take the data. Actually, I'm going to call this gen chunk because that's more accurate. It's not generating the entire world. And this is going to generate the appropriate block faces given the data. And this is going to generate the data. And then here, we're going to do a public void build chunk. And this is going to take data and process it for rendering. And then we're going to do a public void render. This is going to take in a shader program. I'm going to call it program. And this is going to be just drawing the chunk. So drawing the chunk. So we're not going to mess with this. We're going to make some fake little dummy data to make a tiny little 2-block world and see how far we can go with that. So here, what we're going to do is we're simply going to be looping through. I'm going to do a simple for loop here. So I'm going to do for int I equals 0, I is less than, I'm going to do 3 blocks, I plus plus. And here we're going to do a simple thing. We're just going to add a new block to all of these. And so for this, we're going to simply we're going to add data to all of these. So we're going to go ahead and I guess we'll add the front faces for now. So I'm going to do a block equals a new block. This is going to take in a position. So we're going to do a new vec3, and this vec3, we're going to be changing the x. So we're going to do I 0 0. And here we're going to do chunk verts add range, or we're going to do var front face data equals block dot get face, and this is going to take in faces dot front. So now this stores our face data. So now what we can do is we can do chunk verts dot add range, which is going to add everything within a list, and this is going to simply take in the front face data dot vertices, and then we can do chunk chunk UVs dot add range front face data dot UV. And now we need to add the indices, because remember we need to index what we're drawing. And so for this, I have a little thing that I like to do, and this, I don't know if this is honestly the best way, but this is what has worked for me. So I'm going to be completely transparent with you and just say this is what I came up with. This is not ingenious. So I'm going to do a private int index count, and then what we're going to do here is we're simply just going to do public void add indices for face, and this is just going to do we're literally just going to add the amount of indices. So, or we're just going to add indices between a range int amount faces. And here I'm actually going to reference the original one that I wrote. So here what we're going to do, I'm going to go ahead and just show it first. If we go below all of my chunk generation, all I'm doing is I am incrementing the index count every time I add a face, and then I'm adding these with that new index count, because the index count needs to go from 0 to the amount of vertices that we have. And since we use 4 vertices per face, we're going to increment it by 4 every time we add a face. So knowing that, we can do for int I equals 0, I is less than amount faces, I plus plus, and then we can do chunk indices dot add, and here we're just going to do we're going to do 0 plus the index count, and here from int to uint, int from to, did I typecast it? I think I might have typecasted it. Did I? Index count I made it an unsigned integer. Okay, that makes sense because it's never going to be negative anyway. So uint index count. Okay, and now we just want to copy and paste this to make 6 of them, since we have 6 indices per face. And now we just need to look at our indices at the pattern. Remember, the pattern is 0, 1, 2, 2, 3, 0. So we're just going to take that pattern, go to our chunk here, and we're going to do 0, 1, 2, 2, 3, 0. And then we're just going to increment our index count by 4. Okay, so that is our entire add indices. So now we just need to do chunk. Actually, we don't even need to do that. We just need to simply do add indices, and then we need an amount. So for this, we're just going to add 1 since we only have one face, and that will be our entire block. And now we have all this data inside of our different things here. So now we need to simply build this. And the way we're going to build it is just how we do normally. So we're going to create a new VAO, and we're going to use it for all this stuff. So here, I'm going to create a VAO, chunk VAO, and then I'm going to create a VBO, chunk VBO, or chunk vertex VBO, and then a VBO chunk UV VBO, and then I'm going to create an IBO chunk IBO. I believe that's all we need for now. So now all we need to do is just use this in our build chunk here. So I'm going to do chunk VAO equals a new VAO. I'm going to do chunk VAO dot bind, and then we can do chunk vertex VBO equals a new VBO. This is going to take in our data, and for this we're going to do our chunk vertices. And then what we're going to do is we're going to do chunk VAO or chunk vertex VBO dot bind, and then we're going to do chunk VAO dot link to VAO, and then we need to send the location and size, so 0, 3, and then the actual data, which is the chunk vertex VBO, or not the data, but the VBO object. And then we're going to do the exact same thing for the texture coordinates, so the chunk UV VBO equals a new VBO, and this is going to take in our chunk UVs, and then the chunk UV VBO dot bind, and then the chunk VAO dot link to VAO, send it 1, and then 2 because we only have an X and a Y for texture coordinates, and then the chunk UVBO. Now we need to create an indices, so we're going to do our chunk IBO equals a new IBO. This is going to take in our data, which is going to be our chunk indices, and that's all we need, I believe. So now in the render, we can simply do program.bind, and then we can do chunk VAO.bind, and then we can do, oh, we need to actually have the textures, my apologies. So for the texture, we are simply going to bind the texture that we need. And since we're using an atlas, we only need one texture, which makes it very, very simple. So texture. And then here we're going to create our texture. So texture equals a new texture. And this is going to take in the file path. I'm going to make sure I have the file path right. So it should be just this. However, we might have to move back one because we're inside of this folder. I'm going to test that out and make sure. But yeah, let's just make sure that we'll just add this new texture here. And then we'll do simply texture.bind. Now that we've bound everything, we can do GL. Whoa, GL. I need to import OpenGL or OpenTK here. So using OpenTK.graphics.OpenGL4. Now we can do GL.draw elements. This is going to take primitive type dot triangles, and then we need the count, which is going to be our index count actually, and then we're going to need the type, which is going to be draw elements type dot unsigned integer, and then we need just the 0 so we start at the beginning. And this is going to say cannot convert from uint to int. So we might need to do is we need to do chunk indices dot count. Okay, now if all that works, we should be good. The only thing we need to do is we need to simply call these methods. So I'm just going to do gen blocks, then build chunk, and then all we need to do after that is render it, but we're going to call that from outside the chunk. And we're going to maybe declare this as nullable in the future, but don't worry about that. Let's see. So now let's go into our game here and let's get rid of all of this except for the cursor state and all that. Okay, let's get rid of everything that's except for the program. So I'm going to get rid of all this, and I'm going to get rid all of this except for the model view projection. Except I'm going to get rid of all the translation stuff here, and we're just going to have a standard model view projection. I'm going to get rid of this program.bind. I'm going to get rid of the second draw call, and then I'm just simplifying things a little bit. And so now let's make sure that we didn't delete anything critical. So let's run it and make sure. Actually, it won't work because we did delete critical things. My bad. Now what we're going to do is we're going to get rid of all of this render pipeline stuff with all this data. We don't need it anymore. And we're just going to create a new chunk. And we're going to do chunk equals a new chunk. And this is just going to take in a position. Our position doesn't matter right now. We haven't done anything with it. But we're just going to create a new vec3. Just fill it with zeros. And that should create our chunk immediately. And we do need the program, so I need to define that. So shader program, whoopsies. So now we have a program. We're not going to need this. We're just going to need to create this chunk here. So we already created, actually. We don't need to do that. I forgot. What we need to do is create a delete method so we have good memory management. So I completely forgot about that. Sorry. Let's do a public void delete. And then this is just going to do chunk vao.delete, chunk vertex vbo.delete, chunk uvvbo.delete, and then chunk ibo.delete. Okay, that should be it. Oh, we can do the texture as well. Texture.delete. There we go. Okay, now we can get rid of this GL draw elements, and we can do chunk.render, send it the program, and let's build it and see if we have any errors. 0 errors, okay. Let's see. Not set to an instance of an object. Okay, chunk verts was null. This is correct, yeah. We didn't initialize these, my apologies. Let's go ahead and do that in the constructor here. So chunk verts equals a new list of vector3, chunk UVs equals a new list of vector2, and then chunk indices equals a new list of unset integers. Now let's run it, see if we have any more errors. Definitely do, yep. You need to initialize the OpenGL binding first before calling load bindings. Yes, okay, so the problem is that we created the, we called the constructor of the chunk before we actually initialized OpenGL. So we didn't have a context. So that is my fault. I didn't think about that. I'm just going to define it at the top here. And then I'm just going to, in the onload here, I'm going to make sure that everything is defined properly first. Then we're going to do chunk equals the new chunk. And this way, the OpenGL will be, the context will exist before we do that. And now we have one more error, attempted to read or write protected memory. So let's see what this is. Often an indication that other memory is corrupt. Interesting. All right, so I found the error. It's pretty stupid. I forgot to bind the chunk IBO. So now if we run this, what we can see is if we turn around, we have our block faces all drawn with one draw call. And it's only one because we only drew the front face, but we can definitely go ahead and draw the entire blocks this way. So for this, let's just go ahead and do what we're doing here, but for all of the faces. So we could do this programmatically, or we could just do it on top of each other. I'm just gonna, for simplicity, just do them one by one, and then show you the better way in the next video. So here, what we're just going to do is we're just going to add the range of this 6 times. So 2, 3, 4, 5, 6. Actually, we don't want to do that. What we want to do is we want to do this, the entire thing, 2, 3, 4, 5, 6, and then I'll do left face data, right face data, back face data, top face data, and then bottom face data, and then just change these appropriately. So left, right, back, top, bottom. And since we're adding 6 faces per block, we are now going to change this from a 1 to a 6. And then we're also going to change the use the correct variables for these. So right face, right face, right face, back face, back face, back face, front, top face, bottom face. Okay, now if we run it, oh, now we're inside of a block here. And as you can see, we have our 3 blocks using this method here. And what you'll notice is that inside these blocks, we are drawing every face, and you can see this like flickering. This is because we are drawing these faces in the exact same spot. So OpenGL is confused on which one to draw. And so we're going to utilize a very simple chunk meshing here to sort of get the idea of how we can remove this. So basically, what we can do is, I'm not going to use the algorithm yet. What I'm simply going to do is I'm just going to use conditionals, just very basic conditionals for this. So what I'm going to do is, I'm going to do, at the top here, I'm going to do if I equals 0, then we add the left face, and then I'm going to do if I equals 2, since we're doing 3 of these, then we'll add the right face. And that's all we can do for this little strip here. And then now our indices are messed up. We have too many indices for what data we have. So what we're going to do is we're going to create a variable. I'm going to call this int face count equals 0. And basically, every time we add a face, we just increment face count by 1. Face count plus plus. And then since we're adding 4 here for all these, we'll just do face count plus equals 4. And every time we loop over this for loop, it's reset to 0. And so now we just pass in this face count here. And so what you'll see is, since we are only adding the left face on the leftmost block and only adding the right face on the rightmost block, what you'll see is when we run this, we're inside, but as you can see, it's hollow in the inside. And this is the basic idea of chunk meshing. So I can go in here and you can see there are no unnecessary faces being drawn here. So this is a super simple example. As you can see, the algorithms can get quite complex, as I'll show in the future. But this is the entire tutorial, I believe. Definitely a longer tutorial. Sorry about that, it's a lot to cover. But in the next one, we'll get into building a very simple chunk and using chunk meshing. So that being said, thank you for watching. Hopefully you enjoyed this. And with that, see ya next time. Bye guys.